Welcome, good evening, good morning, wherever you are. And right now, I see someone is connecting, so yeah, we can start, I think. And today, we are taking from where we left last time, and I'm going to introduce gently a couple of concepts that we are going to need during our end zone, where we use essentially modules in Dagger to create containers and images for some basic scenarios. We are going to start with that. Then we compose two of those modules to build something new, so we can see how the reuse of different pieces works. Okay, and eventually, if we have some time left, we also see what's already in the Daggerverse, in the registry of all these modules that you can use right away and include in your pipeline. Yeah, I think that would be more than enough for today. So let's get started, shall we? Right, so, let me go to the right desktop, to main screen. Alright. Alright, let's start from this. What happened? Okay. Always this kind of issues. But okay. So I have the stream deck that is not working. I don't know why. Just a second. Alright. Now, no, it's not working. Come on. Alright, I go without stream deck this time. Sorry about that, this inconvenience. So, core types. Let's chill a bit and get started. We are going to build a Dagger module. We already did last time, so let's start and recover from where we left. Just a second. Everything stopped working, but we can make it, I promise. So, no, it's a lie. We cannot make it. Oh, okay. Never mind. So, last time we did something like this, right? You create a folder, you do Dagger init SDK Python, and you're good to go, in the sense that something magic happens. And this magic creates a directory tree like this, where this is the root folder, and then there are different files. One is uvlock. Uv is the package manager for Python, one of the fastest on the planet, so be sure to check it out. It's very useful. And so this is managing all the dependencies of this SDK language. So remember, building a module means using a programming language to identify operations of your pipelines, meaning using the core types of Dagger to define some kind of action that are not properly programming language. It's an SDK to program the GraphQL engine that is underneath, where you launch the engine of Dagger. So you are inside a Docker container where Dagger engine is running, and you build inside this runtime with a particular set of SDKs. One of that is in Python, for instance. We are also going to see Go and then stop, because I don't know good enough any other language that is supported at this time. So there are also many people that are looking into other languages. If you prefer those other languages, I can indicate you who to watch for more information. But in this channel, we are going to go with Python and Go. Okay. So Dagger init SDK Python. This is how everything starts. You get UV logs of all the dependencies for developing your applications. Same for the Py project. Here, keep few things in mind. You can version your project. You can, the name is the one that you, by default, is the name of the folder from which you run Dagger init SDK Python. So here there are some other stuff that are more advanced. So take it as granted. Go ahead. Dagger.json is the core of the configuration of your module. So where you indicate the Dagger module name, the engine version where you build it, I just using the last version, and the kind of SDK you're using. Many other information can go inside here. For instance, when you install another module from the Daggerverse, you can include it here, and it's going to be included automatically by the command Dagger install. So this is the core of the configuration. Then there is a license that is put by default when you create one. By default is Apache 2. And now things start to get serious, because we are going to look at the source code. And the source code for a module is pretty simple at the beginning, right? You have an init file that is importing the class Dagger Python demo. Notice that this is now camel case, and where you define the name of the directory is separated by dash, okay? This is a bit tricky, so pay attention to this. And then here we are with the first version, the default version of a module that is provided by the SDK installation itself. So simple imports of all the core types that you need, the class object that represent your modules, and then for each module you can define different functions. And functions are actually Python function, but that can work with Dagger objects. For instance, we are going to see in a second what kind of object you can use, but one of the most common is container. You see here, this function is returning a container, an object type container that is also a logic instance of a container, and we'll see how it works. This other one is taking as input a directory, so you can pass from the host machine some directories to be imported into your engine runtime. And in this way you can be sure that directory arg will be a proper directory from your host. And yeah, so this is how functions are defined. And there are, in Python, you have a async function and sync function depending on the kind of operation, because when you build a container in Dagger, you have some operations that are lazy and some other that are not. You might be customized to that if you are working, for instance, with Spark, PySpark. You can concatenate operation, but not necessarily they are calculated when you go to that line. It can be synchronized later. Same here. We will see this in action, so don't worry about this. And one last thing. Yeah, here we have immediately an example of how you can build a container in a new way, right? You are used, probably if you follow the channel, in using Docker files. we saw how to use these Docker files to customize different kind of frameworks. And yeah, you still have ways to build container just like you did in Dockerfile, but with some bonus features, right? And yeah, this is the easiest way and the most common one. So you instantiate a container. Container in this way is an instance of container scratch, okay? No, not imported from any existing Docker image. Then you can say, okay, start from an Alpine image. And then this with exec, you can assume or you can think about that just like a run verb in a Docker file, okay? So it's an operation that will be executed inside this container. Done. With exec, it's returning a type container. So in this case, it's not an async function. You are building a Dagger core object called container that is instructed to start from Alpine and do execution of this command. This other one is similar, so you see we start again from container, Alpine latest, and then we have some extra function that we can use from there. So you can mount directory from your host. So with mounted directory, the destination of the mount and the directory. Directory arg, remember, is a Dagger directory type. With workdir means what it means in Dockerfile, workdir. So move your current directory inside the container to this path. And then the final, until here we are at the point of container, okay? Then you ask for the container to be evaluated. So you are forcing an operation that is synchronizing all this small pipeline. And so eventually you say, okay, do this operation and return the standard output of this operation. Of course, to do that, you have to execute the whole thing. And this is the reason for which stdout is there, and we need an async function for this, right? I hope this is clear. Now we are going to see how to use it. Let me just take a sec to exit, if the connection allows me to do that. Okay. And one thing that I cannot understand. Okay, now the connection is good. To start developing, yeah, this is an important part. So you go to the directory with the Dagger Python demo, right? And if you type Dagger develop, all the internal dependencies will be loaded to your file system, so you can use them to actually to have a working environment for your IDE. So NeoVim, VS Code, whatever. It's helping in setting up completion and that function for developing. I'm doing this now. If I do UV, oh, come on, UV run mvim, okay, and now I should be ready. Okay, now we should have completion. And you can see that if I go here to container, you say, okay, this class is an OCI compatible container, also known as Docker container. So I told you the truth for once. And okay, now is everything set up correctly. we can go ahead and type something very nice. That what the all right. So everything is happening today, but don't worry, we can do it. So we are inside the folder with our module. We can already take a look at how we can call this function. So Dagger call will describe you all the possibility that you have. So all the function that you have available with these modules. The module is instantiated the first time, so we can do Dagger call -h, and voila, you see here we have two functions, container echo and grab dir. That is container echo and grab dir. Again, be careful. This is the trickiest part, as always. There are conventions in the name of the function. Underscore in the function module in Python stays for minus in the function here. Grab dir stays for dash here underscore here. Okay. You see then another thing, that the description of the function, this is also cool, is essentially what you put in the doc string of your function. Very good, very useful. In practice, you might notice that this is a self-documenting stuff. Very powerful. You have to focus just on what you want to do, and you can have something that is auto-documented, auto-argument safe, so you can be safe that directory arg will be a directory. Let's check it out. So now, if I want to do grab dir, let's try grab dir. Okay, so grab dir. How can I use this? And you see that is grab dir directory arg pattern, directory minus arg from here, and pattern from here. Pattern is a string. They are both required. So now we have, if you do directory arg, and we say dot slash and minus pattern, and we say let's see dot py. Okay, host directory is taking this and voila, so it's grabbing the result. Let me put this a bit bigger. So here it is. Grab dir taking this is loading all my libraries in virtual env, is finding the py recurrence inside the files. All right. So looks good. And the first step was taking my host directory and loading into your container. Now, one cool thing is that if I do this again, I suppose. So let's do this again. Okay, you see, it's consistent and you can reproduce this everywhere. But one thing that I wanted to show you is that if I put here something else, I got an error. I got an error because Dagger is making sure that the argument that I'm passing here is actually a directory. So it's looking for that and saying, no. There is no such file or directory. Cool. Any question? So let me see. Okay. I see none, so let's... Yeah, I can wait a couple of seconds. Because there is some delay. Okay. No questions. Perfect. Now let's go ahead, should we? And let's start building something on our own. Let's say last time we built a Ubuntu plus Figlet, if I remember correctly. This time the plan is a bit different. And the plan is the following. We need to take two modules. One module will be made in a way that you compose a message and you put it into a file. And the other module will import the function that you have in the first module and use it for building its own image, right? So how can we do this? We start first of all from implementing our nvim uv run nvim this and main.py. Okay, so let's scratch this, and we are going to make something like a container dump, and then we transform this, for instance, in bash -c equal okay -c 2 okay -c equal string, and we put this into cache file output. All right, so what I'm doing here, it's simple, but it's also interesting because we do string arg, and okay, perfect, string unterminated, right, so all right, so I have, what am I doing? Don't look at this, ignore it. So bash -c for my excuse, it's a long time and do not code in Python, okay? Don't I mean? But yes, okay, so now looks good. Yeah, pretty much. Okay. Oof. What the? Okay, I lost this terminal. Good. A nightmare. Dagger demo. Let's try again. Dagger Python demo. UV run mv src Dagger main. Okay, now it's working. Now, this is our function, okay? It's returning something and with mounted cache. Okay, and if you go to cache volumes, these are how they are supposed to work. So with mounted cache, a cache is a persistent volume that persists in different runs of your pipeline. Okay, so there is a folder inside your engine where you can write things that are persistent. Otherwise, every time you do a new Dagger call, everything will start from scratch. Okay, this is the rule number 1 of the modules. Now, let's start from this and say, okay, with mounted cache, the path here is cache, is /cache, and the parameter is dag.cache volume and a name that will identify the cache volume. So test, no. Let's pass to our module a variable that is called name, that is a string. Okay. Of course, it's not this the syntax. Let me check. Okay, we can do it another way for the time being. Right. Name. Okay, let's try. This is the correct way to proceed. No, it's not possible. I'm doing something wrong. Okay, let's try Dagger call -h right now. Fortunately enough, if I didn't mention this before, I'm going to remaster this episode, so you will find all the pieces correct without losing too much time with that. So I don't know if it's a good or bad thing, but it's a thing. All right, container dump. We have it. So container dump -h. And you see it's a container, so you can do all these things with a container. And as an argument, it takes string arg. Okay? So if I do minus string arg ciao, then I have all this operation because I have a module that is returning a container, and these are all the functions for a container. One of those functions is terminal. That means opening an interactive terminal inside the container that you're building. So let's do it. Terminal. So it's taking this and it's trying to echo ciao inside. Okay, what's the error? It's the fact that we did not save things in here. Okay, never mind. UV run vim src main. I don't know. We need to refix this. And yeah. All right, so okay, we can make it somehow. It's taking this, is reinitializing the model because I changed it, and nope again. Bash is not executable file. Are you kidding me? Didn't we have? Oh no, okay. Yeah, it's an Alpine. All right, we are close to make it working. We need to remount with mounted cache. Cache dag dot cache volume name. All right, and name is self dot name. Okay, now you see an error because probably because there is an extra argument that I had to pass to the whole module. This means that without this option that identify, I usually use this to identify my pipeline. So if you have persistent data on your pipeline, you can use cache volume with a name to persist those data during all your tries. Okay, that's cause way to make things persistent even if you are in different tries. So name SciX, this is our tries. Now should have a terminal opened, and voila. So I'm inside the container I just built. If I go inside cache, I have my file output that get ciao, as I mentioned before. Now one thing, I don't know if it's working, but we can try it quite easily, is the persistence of the cache. We can check it right away. I can type ciao ciao and put this into output. Now if I exit and I redo this again, so I'm in a different try, hopefully if I told you the truth, I have ciao ciao. Okay, so cache volume first, very good thing when you build stuff that you don't have in other systems, at least with this dynamic and interactive way of developing stuff. So you see, you can code, test, retry, and so on and so forth. And you will be able to rerun this on your pipeline just like you are doing your machine. The isolation and the engine provide this kind of strength. Alright, now we can exit. We have a container that is doing what we want. There is then a concept called chaining function. Chaining function is a function like others, can be def. We can tell append smile, append smile self, and self and file, dagger.file. Dagger dot file. Yeah, I'm writing in Go, I am programming in Python. This can be more wrong. So okay, and then the output of this will be a type self. Okay. What does this mean? It means that I can now concatenate append smile with any other function in here. Okay? Actually, we need to do the opposite. We want to fill the file and then append a smile after the message we print into output. So this function will transform it and say, okay, self, of course, it's returning something that is not good. return self, and then this will return a Dagger container. A Dagger container. All right. Now, here we do the following. So, no. Oh, help me. What's happening? I'm gonna find out what's happening. But not today, I suppose. Complete this stack. I mean, it should be something obvious that I'm not seeing. But okay. Okay, fortunately enough, we have stuff here. Allow me to do this briefly. Okay, and then I have return stuff. And then here I have okay. I have Dagger dot container. No, container. Come on. Dagger container. Okay. Perfect. Now return, and we do something like this. We return the container as before, but this time we want to append a smile. Okay, so we append a smile to our volume. Now if we run this, we are going to have some trouble because we have container dump that is doing something, but you might see already here this container will never ever be evaluated. Okay, so in order to do something useful, we need to persist a container during different function calls, and one way to do this is my container Dagger the container, okay, and doing here self dot my container equal this thing, and guess what? From here you can remove this and this and say okay, self dot my container, and you're good to go. right? You have to pass a file. So I don't remember. Let's see if this is a good way or not. So no, I think I cannot do that. Okay, file dot not content name. Yeah, I hope so. So now I can do something like this and concatenate the two. The two, if I only remember, append smile. Okay. So now I can have this, and then instead of terminal, I can do append smile minus minus file, and the name of the file that is cache output. Yeah, I'm going to be in trouble for the validation because file will return an error because it's not a file on my host. Let me check, but I'm almost sure. So container dump will run first, build the logical layer without evaluating. All right. Let me see if I can do Dagger put a container. Let me see. So core types, file directory container, no. Engine, custom runner, no. Working with modules, here it is. No. Optional arguments. All right. Or known was easier than expected. So it's Dagger dot container or known. Okay. Right, now we have to do if self dot my container return this. Okay. Else return dag.container. Okay, let me try that this way. I put I put the optional argument, and now we have some trouble that are actually what I mentioned before. So cache is not a file on my host file system. So what we need to do is to go back here and say, no, I changed my mind. This is not a local file system. This is not my local file. It's a file that will be created inside the container. So I have to put string here. And go here and say file. Launched again, and voila. Let's see. This time we should get what we are looking for. Exactly, I have a container. So we can tell now terminal and see if we did append a smile to our text. So if we managed to chain two different functions. All right, we are there. So cat cache output. All right, almost. We have just a smile, so it's not good, but it's not good because we did not append. We just overwritten. So now this is the right time to put in practice what we have, and voila. So we are appending a smile. You see here the result? Look. So the result is that the first function was lessly evaluated until here, and then the final operation has been appended. So you have a Docker file that is just one, that is the result of the two functions that has been chained. And now if we go and say cat cache output, we have two smiles. Why we have two smiles? This is weird. This chow should have been put there. Let's try this. It might be that since everything goes in parallel, if it can, this stuff went in parallel without possibly being able to do it. Let me try another thing. Let's try change the cache that we use. Now we have nothing. How is this possible? I'm returning a container. self my container. So it's not evaluating what we have. Any idea? No? Self my container, self my container. Self.name dot name. So okay. What I'm missing? Something obvious, but I can't see it. Cached. Okay. Now I see. Now I see. What happens is that this function did not change, so it was cached. So the file is not recreated every time. Let me try this. We should invalidate the cache. And the caching is here in the cookbook, I think. Okay, remember it's a cool thing now, an elegant way to invalidate the cache, and if I remember correctly, is in the K3S module. Let's open. Okay, this is go, but yeah, it's good enough. We mounted, yeah, this one. So if we say here with env variable name cache and as values value we put time now okay, come on, Python time now. All right. Okay. And we need to close this. Import date time. let's see if this is working. So okay. So now we are chaining, we are invalidating the cache. So even if not present and we did not change an operation, they should be triggered again. Let's check it out. Cat cache output. All right, voila, we are eventually there. So it's tricky, but it's interactive, you see? We change, we try again. And yeah, live reload. I hope there is something that is going to come someday. That will be the final feature, really. The game changer, really. So imagine you prototype your module on one side and it will be live reloaded inside your shell on another side, on another session. That would be awesome. But okay, now we can survive with this. I think it's pretty cool. And we appended container dump function and we append a smile. So this is chaining. We saw cache volumes. We saw how we can instantiate a module from scratch, passing some command, mounting a cache, invalidating the cache when needed, and we are ready to go, right? To go where? Well, there are different kind of things we can do now, but I like to close this session that was meant to introduce to the module. So the publication and the reuse of external ones will be delegated to the next time. But the cool thing that you can do now, and this is a live experimentation, so brace yourself. You can imagine, okay, let's keep this on one end. That is command that we ran before. Now the magic that has been publicly released recently, yesterday or the day before, is what we call Dagger shell. Dagger shell makes the shell that we all know with the capabilities of Dagger engine. So you can call the primitives, the core types of Dagger, instead of doing or writing a Python code, doing actually bash scripts. So let's take a look. I can do help and it's showing me these things. So for instance, it tells me, okay, I have a generated module called Dagger Python demo, and if I type dot help Dagger Python demo, it says, okay, you can do dot name and a series of options. Argument that is optional is container, and you can go ahead doing this. Container dump returns a container that equals, and the description goes, we didn't change the description, we should, but never mind. So I can do psi, okay, that is the one before, and at this point I have completion. I can call, let's see if I can call, no. I can do, actually, append smile. And the file, minus file will be cache output. Unknown flag. Ah, okay. Usage name pipe.help. Okay. Okay. Append smile minus file. Right, it's a pipe. I'm a bit tired. Sorry. So it's a pipe. Append smile and cache output. One positional. Okay. Okay, it created the container. Well, actually it did append another smile. Then we are going to append another smile plus terminal. Terminal. No. All right. sh executable, no, file not found. Dot help. Okay, so this is creating a container and the terminal. Why the terminal doesn't start? Okay, never mind. Wait. Exec. With exec, and we do cat cache output, and we do this std out. Executable file not found. sh -c. with exec. Okay, this is not really nice, but looks like it's needed. Maybe. Let's see. Okay. No, in fact. Like this. Okay, this one should work. Sage with exec. Append smile. So if I do this, that is the same that we did before. Let me check if it's working or not, just to be sure and I'm not getting crazy. Okay, so at least we are getting the same error inside and outside the shell. So I suppose right. Okay, right. It's because there is no my container. Let's see if I can do something like this. Container and container from Alpine. From Alpine. So I'm substituting the first function that was setting the image. What's happening is that the image from where I'm starting with append smile, it's not an Alpine image, it's a Scratch one, okay? Because there is not the previous function, the one that I chained before, that is setting the stage for the append smile function. Whew, so good. Now it's matter of understanding if I can easily set with cache. Okay, we can do this in 2 steps. Yeah, this is failing. Now we can set my container probably to something like this with cache volume, cache and psi, and then I can tell start from this container. This is If it's working, it's pretty damn good. So container, you see, I created a container, a first function returning a container before, then I use the value of that container to start my pipeline. And now let's be brave. Okay, so it's container with mounted cache. Come on, with mounted cache and cache volume psi. Okay. All right. It takes some time, you see, also to myself to get accustomed to this kind of syntax, but now hopefully we should see a smile. Okay, so the smile is there because nothing was set on that cache by our first step, that is my container we set with this and that. Now I can try another thing. I can try the chaining. So I can tell why did I exit? So I go back to this situation and I want to change the original function. So was dump container or what? Echo dump? No. Okay. I surrender. Dot. How it's called? Container dump. Okay. So here we start from psi again, but then we tell exactly container dot container dump ciao. So now what we should see here is cache output. Voila. All right, we have some material to be remastered and put into the channel. I'm happy. I don't know you, but yeah, I think we have something. So to summarize what we did, let's exit and see. We created a module called Dagger Python demo, where we have a function called container dump that is a chain function, so it's returning a self type, and it's putting some information into a file, and this information is string arg. It's the argument that we pass. So it's a string, it will dump the information into a file that is cached, so to different runs we still find those informations, and we demonstrated that. Then we have the append smile, that is a function that is returning a container, and this container is actually should already exist before running, and it will append a smile to a file that we indicated in the argument, right? So next time we also can add file default value in here, but yeah, let's see. And what we did is demonstrated through different Dagger call how to use it. Then we did Dagger shell, because it's the new nice thing that is being implemented. And clear function, no. So, and what we did is creating a container with a cache volume and put this into a variable, environment variable that will be like an environment variable in bash. And then we reused that environment variable as a container type to bootstrap our myContainer argument in our function. So our module, we pass the name, that is a positional argument now. It's called sci, myContainer, and myContainer environment variable, that is this one. Then we piped this into an append smile function that is pointing to adding the smile into output. And the terminal showed us that the file containing only a smile, because we were starting from scratch in here. Then we try to replicate the chain that we did before. So we take the chaining function that is container dump, we put some information, and we pipe, simple like this, append smile to that. So you can develop and you can start playing around. Here I can start already. This is a container, so I can continue and say, okay, exec with exec sh minus c echo ciao append again. Okay, so I can programmatically test and play with these features in this way. So cache output, and then I pipe into terminal. Yeah, probably right. What about putting thing in the right place? Okay. Yeah, of course. I'm still repeating the same error. Okay. I'm doing stuff. What happened? Can't open minus C. SH minus C equal ciao. Are you kidding me? Oh, and what about this? No, this way is not going to work. Yeah. Well, as soon as I discover how this minus C work, I'll let you know, guys. But yeah, you can add whatever you want. You got the message, right? This was kind of a crazy session. But okay, so what else we can do? What else we can talk briefly? We can take a look at what we are going to do next time. That is essentially taking our volume and put it into this nice registry, right? We do some series module. We are going to create a module for creating a virtual machine on a public cloud. and we put this into the registry. So we see how we download and load locally modules, and now we can compose them. Yeah, probably we also see how Go works, and I promise I will be better. That for sure. Than with Python. But I know many of you that are looking for this channel are using Python, so I did the effort to pretend to know how I'm doing in Python. So I hope you appreciate the effort. So now, of course, my Dagger stream is not working, so I have to do this way. That is crazy, but yeah, okay. Thank you guys. I'm going to summarize in a new video all this stuff, so you can get more compressed and just the core information. And we keep accumulating this kind of example in the channel, so we will have a complete course without having to get mad with 90 minutes episode of me yelling at the terminal that is not doing what I want it to do. So thank you for watching, for stay long, and have a nice weekend. And see you at KubeCon next week. There are a lot of episodes coming. We are also have news for the podcast where there are some CNCF project that will be our guests. So stay tuned and see you in the next time. Bye bye.